Topic 3, Sequences and Series. 3.1, Sequences and Series. 3.2, Binomial Expansion. There are two types of sequence, that is finite sequence and infinite sequence. Definition: a sequence is a set of numbers arranged in a particular order, such as A1, A2, A3, and so on. A finite sequence has a fixed number of terms. A1, A2, A3, AN or TN, where A1 is a first term, A2 second term, A3 third term, AN or TN is the nth term. An infinite sequence has an infinite number of terms. A1, A2, A3, AN or TN, where A1 is the first term, A2 second term, A3 third term, AN or TN is the nth term. Example 1. Find the first 5 terms of the sequence defined by Tn equals to 2n minus 1. Replace n in the formula by each integer from 1 to 5. T1, 2 times 1 minus 1 equals to 1. T2, 2 times 2 minus 1 equals to 3. T3 equals to 5. T4 equals to 7. And T5 equals to 9. The first 5 terms are 1, 3, 5, 7, and 9. Example 2. Find the first 4 terms of the infinite sequence defined by an equals to negative 1 to the power of n minus 1 times 2 power n over n. Replace n in the formula by each integer from 1 to 4. A1 equals to 2. A2 equals to negative 2. A3 equals to 8 over 3. A4 equals to negative 4. So, the first 4 terms are 2, negative 2, 8 over 3, and negative 4. Example 3. Write a formula for the general term of each finite sequence: 2, 5, 10, 17, 26. We see the pattern of the sequence where 2 is equal to 1 plus 1, 5 is equal to 2 square plus 1, 10 is equal to 3 square plus 1, 17 is equal to 4 square plus 1, and 26 is equal to 5 square plus 1. Now, the general term of this sequence is an is equal to n square plus 1, where n are integers. Example B. We see the pattern of the sequence also. 3.1 is equal to 3 plus 1 over 10. 3.01 is equal to 3 plus 1 over 100. 3.001 is equal to 3 plus 1 over 1000. 3.0001 is equal to 3 plus 1 over 10,000, and 3.00001 is equal to 3 plus 1 over 100,000. So, the general term of this sequence is an equals to 3 plus 1 over 10 to the power of n, where n are integers. Definition of a series. A series is the sum of the terms of a sequence. If A1, A2, A3 until An and so on is a sequence, then the expression A1 plus A2 plus A3 plus until An plus dot 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 is called a series. If the sequence is finite, the corresponding series is a finite series. If the sequence is infinite, the corresponding series is an infinite series. Example of finite series. Example of infinite series. The table shows the difference between sequence and series. Finite sequence, example, 2, 4, 6, 8 until 2 to the power of n. Finite series, example, 2 plus 4 plus 6 plus 8 plus until 2 to the power of n. Infinite sequence, example, 1 over 2, 1 over 4, 1 over 8, and so on. Infinite series, example, 1 over 2 plus 1 over 4 plus 1 over 8 plus 2 infinite numbers.